Mm. Hello, can you hear me?
Yes.
How are you guys doing? Um, Enorme. Who is Enorme here? Oh, all right. Today, let me start by showing you the screen. My screen, the announcement. Set class. So, for the announcement, you can see what you are required to do this week. Okay. So this person. All right. Now you can see the announcement. We're now in week 12, and we're still on the chapter on confidence intervals. 2 assignments due this week. Actually, just one, which is the homework 8. And it has been there for a while since last week, so complete it this week. The other one is semester project. That one is due on December 1st. But I put it here. I made it available so that your group will start working on it if they want. This will be a group project. So I want you to select your group, not more than 5 people in one group. Select your group, write your name down on a piece of paper, and submit to me on Thursday for my approval. Once I approve it, you and your group can start working on the project. Now, where is the project located? Of course, you can get it from the model. I'm going to show you in a minute. If you go to the model on the left navigation menu, consider here, click on it, you go all the way to where we are, which is week 12. This is the assignment for the week homework. There is no classwork this week, so don't worry about this. I'm going to remove this. I'm going to move it to another week. Just the homework and the project. This is project right here. I'm going to click on it. So you can download it from here. Now, watch these 2 videos before you start working on the project. You get a lot of insight on what to do. Okay? And don't forget to bring your names on Thursday of your group. It's a group project. Having said that, I think I've given you enough information to start. So let's go and begin. So last week I introduced you to confidence interval for the mean, and we did some examples, and then we come to the point where we started working on confidence interval for the mean when the population standard deviation is unknown, which is this one. When it's unknown, and it's on population standard deviation is unknown, and the sample size is small, which is less than 30. And I showed you some examples how to use the student t distribution table to find the critical value and the error margin. I also equally show you how to do it on using Excel. So we need to finish one question. This is one we solved. There's one more question we want to solve on that section where this type, if you're given this type, how we can do it. After that, we can now move into the confidence interval for proportions. So let's start with this one. It says, which is a confidence interval for the mean. The last question in that section, when the sample size is given, but you don't have the mean and you don't have the population standard deviation. How you do it? So it says here the following data sets. The following data set represents the sample of the number of home fires started by candles in the past several years. Okay. And it says you find these are the list 5,460, 5,900 home fires. It's a find the 99% confidence interval for the mean number of home fires started by candle each year. In this case, they didn't give you the mean, so you have to calculate the sample mean by yourself. They didn't give you the population standard deviation, which means that we have to calculate it by ourselves. They give us a list of numbers showing the number of amount of home fires started by candle each year. For how many years? 1, 2, 3, 4, 5, 6, 7. So the first thing to do now is to put all this information into Excel. I remember I told you that Excel method will help you get your answer quicker and faster. So let's put it in Excel and then find the 99% confidence interval. So I put all of this in Excel. You can see right here. I have them in Excel. What is my Excel? I think it's right here. Okay. All the numbers are here. I think you can see, I believe you can see this now. So the first thing to do is to find the mean, find the standard deviation. Sample size is 7 already, of course. 1, 2, 3, 4, 5, 6, 7. All right, so I can just type in 7 right there. That the mean, we need to find the mean, find the sample standard deviation, find the confidence level, which is, they told us to use 99%. Let me just verify it again. Yeah, 99% confidence interval. Okay. So we have it here. This 7, this is just 7. I don't know why it's going to that. Oh, excuse me. Just 7 number. Anyway, the confidence level, and then we'll find the error margin. Then on the lower side, we subtract the error, on the upper side, we add the error. That's all we need to do. Okay. So let's find the mean. Mean is the average. So type equal average, pops out, average. Double click on it, and then, highlight it. Press the enter key. That mean sample standard deviation equals STDEV dot S, since it is going to be sample, pops out, highlight it, press the enter key. That's a sample standard deviation. Now, excuse me. Confidence level is 99%, 0.99. So let's find the error. Error simply means to find the error, put equals. Now, because this is a sample of 7, sample size is small, and we don't know the value of the population standard deviation. So that means we're going to use student T distribution. Okay. So just do confidence dot T. Double click on it. For the alpha, do 1 minus the confidence level. 1 minus the confidence level. Then you put comma. The standard deviation is this one. Click on it, comma. And the sample size is 7 here. Click on it. Then close the parentheses and press the enter key. See, it gave you the error margin. Once you get the error margin, you can now find the lower interval and upper interval. See the formula right here. X bar minus error. On the left side, on the right side, S bar plus error. So this is give you the lower interval, this gives you upper interval. This is the mean you're trying to estimate right here. So you have equals S bar minus error, and S bar means sample mean. This minus the error margin, it gives you this. Okay. And on the right side, the upper interval to equal, click on the S bar again, which is mean, plus error this time. Error right here. So this gives you the upper and lower intervals, okay? So now we can conclude. And let me put a text box so that we can now write the conclusion, okay? Inside the text box. So you're gonna go all make it like this. So now, before we conclude, I call it interpretation actually. Okay. I'm gonna make it 18. Make it so it can be clear. Now, look at the question again. The question was about home fires, right? Say that the following data represent the sample of number of home fires started by candles in the past several years. So, since we have found the interval, we can now write our interpretation. So we can say with 99% confidence that on average, you must mention on average, otherwise your interpretation will be wrong. Not average, because I'm trying to estimate the mean, you must mention the average. So on average, between that case, that place you mentioned the lower interval, which is 4,784.992. Now you mentioned the upper interval, which is 9,297. Okay. Home fires. Home fires. Fires are started by candles each year. Candles each year. See, that's it. So you see, if you're using formula, it takes you longer than this, but this you can see how we finish this in a few minutes. Now, any question to this? Any question to this? No question. Excellent, excellent. So now we can now proceed to the confidence interval for proportion. We have concluded the confidence interval for the mean. We look at the proportion now. When we say proportion, we are referring to a part of something. So it's a part of, proportion is a part of a whole. So a good example, according to USA Today, I mean, this is an old news, but I want to use it to illustrate what a proportion is. You see, according to this newspaper, 12% of the pleasure boats in America were named Serenity. That 12% is a proportion of all the pleasure boats in US, 12%, which is a part of the boats, the pleasure boats, all the pleasure boats owned by people. So that 12% is the proportion of boats that are named Serenity. So of the boats owned by people, out of which 12% are named Serenity. Yeah, that's the best way to put it. So now, a few things we need to know about proportion is the P is the population proportion. When we do confidence interval, that is what we are trying to estimate. We are trying to estimate the population proportion using the sample proportion. So P hat represents the sample proportion. And we get P hat by doing X over N, okay, where S is a part of the sample. Now, Q hat is 1 minus P hat. Once we have these two, we can now get the error margin by using this formula here. What's Z alpha over 2 times the square root of P hat times Q hat over N. Okay? Over N. Now, Z alpha over 2, I've showed you how to find it last week. When I showed you that you can use the table of normal distribution to find it, or you can use this table. See, for 75%, critical value is 1.15. For 80% is 1.28. For 85% is 1.44. For 90%, it is 1.645 or 1.65. For 99% is 1.96. Sorry, for 99% is 2.58. And for 95% is 1.96. I believe you can see all this. Now, if they are given, yes, you can use it. If they're not given, I will show you how you can calculate it. I've already shown you that in the class as a matter of fact, but I'm still going to show it again to refresh your memory. Let me write this down and we can enter it on the table. Then I can show you how you can get it. 0.90 is at 90%. So 90% will be 1.645, which is 1.65. 95% is 1.96. 99% is 2.58. Okay. Now I'm going to take you to the handbook workbook so you can enter all this. What if we found on the table for 90 is 1.65? Okay. I'll make sure everybody is on the board. Okay. Then for 95%, we have on the table is 1.96. Then for 99, we have 2.58. Now they didn't give us for 98, so we can calculate it by ourselves. Let me show you how you can do that. Like I said, I've shown you this already in the class, but I'm going to show it again. Let me get the formula for finding it. It's right here. P over 200. Now, why are we saying P over 200? Because percentage is over 100. But for confidence interval, we're looking for the lower side, upper side. So two sides. That's why I use, actually it's a shortcut formula that I use. I use this shortcut formula to find the critical value for confidence interval because it has two sides. Even in test of hypothesis, you can also use it for two-tail tests only. So they didn't give us 98, and I'll show you how you can get it. We use this formula. All of them, you can use this formula to get all of them. But they didn't show us 98%. I'll show you. But before I do that, I want to show you what this alpha means. Okay. Alpha is the probability of committing type 1 error. Anyway, let me put it this way. If you're 90% sure, then your chance of being wrong is 10%, which is 0.10. That becomes your alpha. If you are 95% confident, your chance of being wrong is 5%, which is 0.05. That's your alpha right there. If you're 99% confident, your chance of being wrong is 1%, which is 0.01. That's your alpha right there. For 8%, you got to be 0.02. Okay. Now, like I said, you can use this formula to get the critical values. I picked the one that I give a show on the table, but I'm going to show you how to get it if they're not listed on the table. Like this number by 98% was not listed. So to find it, we're going to use this formula, shortcut formula, which is P over 200. Okay. Which is P, this time around is 98%, so it's going to be 98 by 200. So I'm going to go to the calculator. Where is that calculator? Okay, we're going to find out where it's located. 98 over 200. Give me 1 minute. Right, I found it. So I use 98 over 200. So I got 98 divided by 200. 0.49. 0.49. So 0.49. 0.49. Because the numbers in the normal distribution table are 4 digits. You're going to make complete with 004 digits. Let's go and look for that in the table. In the table of normal distribution. For the value that corresponds to that 49. This is the table of number distribution right here. 0.49, look inside the table. If you don't see a number that exactly matches it, choose the one that is closest to it. I think our answer was 4900. I mean, ignoring the decimal point. So 4900, we look for 4900 right there. If we find the exact match, very good. But if you don't, we estimate it. 4900. I got 0.49, 4849. See, 4900 minus 50, give me 2 points. Then this one minus 4900, give me 1 point. I mean, you can check it. You can say, what? Okay, 4900, for example. Ignore the decimal point. 4900 minus 4849. Okay, right, that's what they have there. I think yeah, 4898. Sorry, my mistake. 4898. My mistake. Let me look at it again. Yeah, 4898. Okay. Yeah. Right here. 2 points away. You can see it's 2 points away. And if you check this one, 4900, 4901 minus 4900. I mean, this one is very clear. It's 1 point away. So that's what we need. One that is closest. So he has only 1 point away. So follow it to the left. 2.3. Follow it up. 3. 2.33. So you go and put 2.33. Okay. 2.33. So that's how you get the critical values here, 2.33. I mean, if they are not provided on the table. Now, having explained that, we can now try one example on confidence interval proportion. Look at this question here. It says, let me move it down so you have enough room. Okay. It says here, in a random sample of 200 investment advisors, 70 recommended information technology stocks. Okay. It's to give the maximum error with 95% confidence. Then construct a 95% confidence interval for the true mean. Okay, let's list the numbers. We have our summary statistics here. We have that how many of them? 200 investment advisors. So our N equals 200. Out of which 70 recommended IT stocks. So X 70 recommended IT stocks. So we need to find the P hat and Q hat. Okay. So let me write this down first of all. This place will not allow me to put the formula in. I'm going to write this down. N is 200. X is 70. So we need P hat and Q hat. Okay. So the formula for finding P hat is right here. X over N. Like I said, this place will not allow me, so I'm just going to copy it from here. Okay. Go to that other workbook. What is it? What is it? What is right here? And then paste it there to share it. Okay, right here. P hat. I'll make it a little bit bigger. The quote S for N. Of course, you know that our S is 70 out of 200 investment advisors. So let me double check it again because we need to be accurate. Yep, it says in a random sample of 200 investment advisors, 70 are recommended IT stocks. So 70 is our X. Okay, 70 out of 200. So let us put it in a calculator. 70 divided by 200. Give me 0.35. 0.35. So I copy this, paste it in our memo book so we can go from there. Okay. Yeah, that's a p hat. Q hat is 1 minus p hat. So I'm gonna put Q hat. Let me write my p hat down, which is 0.35. Q hat. Let's find the Q hat. Okay. Q hat is 1 minus p hat. So I have Q hat equals 1 minus p hat. Okay. Which is our p hat. We got it as 0.35. Okay. So 1 minus p hat to be 1 minus 0.35. The 1 minus 0.35. Okay. 1 minus 0.35. Okay. So let's see what we got there. Yep, that's what we got. So I'm gonna get the answer from calculator. So get 1 minus 0.65. That is 0.65. So I'm put it right there. 0.65. I'm gonna copy this and paste it into our main workbook. Accurate. So next thing we need to get is the error. Once you get the error, we are finished with it. Because the first part of the question says to give the marginal error of the estimate. That's part A. So the right part A now here, part A. Okay. To find that, this is the formula we need, and we're gonna use it. See the you can have it somewhere here. See the error. See equals z alpha over 2 times square root of p hat times q hat over n. Okay. Z alpha over 2. Okay, so let's make copy. I have copied it. So I'm gonna go to the book so I can put it right there. Okay, put it right there. Oh, excuse me. I didn't I thought I copied it. I didn't copy it. All right, so let's go back. Gonna make us right here. Control C. Inside this workbook. Control C. So I'm gonna make it probably 18. I'm gonna erase this part so we have enough room. Equal CC Z alpha over 2 times square root of p hat and square root of n. Now this Z alpha over 2, I showed you how to get it. But also you can get it from the table. Like for this one, it said 99%, 95%. So that our Z alpha over 2, which is the critical value, what is it? Z alpha over 2 for 95%. So I listed it on the table above. You can see it on the table. For 95%, it is 1.96. So have Z alpha over 2 alpha over 2. Make it big so you can see it. Z alpha over 2. Make it 18, of course. Make a slight adjustment to it. So it's 1.96 for the table. So now we can find the error. So 1.96 of Q is 2.65. Let's go and plug this into the the formula to find the error margin, which is equal to 1 alpha over 2 is 1.96. Okay, times square root of, okay, right. P hat is, remember the P hat and Q. Let me refresh your memory. That N is 200, P hat is 0.35, Q hat is 0.65. So I've refreshed your memory. Going back, P hat will be 0.35 times 0.65 over how many? 200 embedded advisors, which is, so let me write this down. Then plug it into the calculator to get the final result. Okay, I got error equals 1.96 times square root of 2.35, 2.65 for 200. Let's go and put it in the calculator. Okay, we have 1.96. Okay, times square root of 0.35 times. Okay, 0.35, 0.35. Okay, oh, excuse me, sorry, right. 0.35 times 0. Over 200. 0.6. Okay, what would I miss? Okay, right here. I really put the decimal point here. 0.066 rounded. 0.066 rounded. Okay. 0.06. So we got the error margin. We'll answer the first part. I'm going to copy this and then paste it in a memo book. Right. So here, so we got the error margin. So part now we answer part B. Part A say part B. Sorry, we answered part A. Part B say construct a 95% confidence interval for a true proportion. Okay, so that means the 95% confidence interval is given by this. That's part B. Is given by this formula: P hat minus error. I mean, on the left side you subtract error, on the right side you add error. Okay. P hat is 0.35. Okay, 0.35. Excuse me. Okay, minus error. Our error is Our error was 0.066. Okay, less than the mean, less than the proportion. Let me put the symbol less than. Less than the proportion, which is P. Okay, less than on this side. Okay, less than again. So this time we have P man, just P hat plus that means 0.35 plus 0.066. Okay, 0.35 plus 0.066. So that will give us the final answer to that. Okay. So 0.35, let me write this down. 0.35 minus 0.066 for the calculator. 0.35 minus 0.066. Okay, I've got 28.284. 0.284. So on the that's we go and put right there for the lower interval. Okay, so this got 0 point. Yeah, less than P. Let me copy this. Less than P. So less than you just time 0.35. Yeah, that's what I get for P, 0.35. Then okay, 0.35. Okay. What is the calculator right here? If you change it to plus, give me 0.416. So go and put right there. So you can see that this 0.284 represent 28.4%. But 416 represent 41.6%. So we can conclude now we are 95% confident that between 28.4% to 41.6% of investment advisors recommend IT stocks. Any question, guys? Hello, guys. Any question for me on this?
No.
Right, don't go here. Let me check your names. Make sure I have everybody's name here. If I don't call your name, then that means you're good. Bullock, I see Bullock. Bullock, I see Bullock. Sinelu. If I call your name, you can also leave. There was here. I got Chin. Got him. All right, let's see. Courtney Akuzu. I think I have already. Okay, you see. Third, I got Darlene. I got Lynn Ellie. No, I got Bobo, James Bobo. Got him. I got Jessica Halley. Got him. Carter. Kennedy Green. Got that one, two. Bullock. Most of it again. Kimura. Butler. I got Butler already. I got Hines. Veronica Howard. Well, I got Boykin. All right, guys. I think I got all of you. I will see you guys to on Thursday. Don't forget to form your group, get your group names, write them on paper, and bring it to me for approval. Not more than 5 people in a group. Now you can go and vote to cast your vote, okay? And I'll see you guys on Thursday. Have a nice day. Okay, see.